right, matrix addition. Given two matrices of the same size, the matrix obtained by adding the corresponding entries of the two matrices is called the sum of the two matrices. So you can say we have matrix A and matrix B, so if we're trying to find the sum A plus B, we would add the corresponding entries or numbers in the matrices together. Now you can only add two matrices if they are the same dimensions. They have to be the same corresponding number of rows and columns. So notice how this one is 3 rows by 2 columns. And this one is also 3 rows by 2 columns. And that means we have corresponding numbers. It's going to work. What if they weren't the same dimensions? Then what would we have to say about adding them together? We can't do it. It's undefined. It's not. There's no matrix definition for two matrices that are different. It's just some thing. So I don't know. I don't care if you write this out the way I'm going to do it. I'm just going to make this exceptionally clear that I'm adding 2 and negative 1 together, and I'm adding 3 and 4 together, and I'm adding 4 and negative 5 together. I'm writing much more than I normally would if I was just doing this on paper, like my assignment or something. And then negative 1 and negative 3 are adding together, and 0 plus 8 are adding together, and then negative 7 plus 1. So I've just taken those corresponding numbers in each spot, like just, 2 plus 1, those right there, etc. And that gives me my result. So still have it in notebook. So 2 minus 1 is 1, 3 plus 4 is 7, 4 minus 5 is negative 1, negative 1 and negative 3 is negative 4, 0 and 8 is 8, and negative 7 and 1 is negative 6. There is the sum of my matrices. Easy peasy. Cool. So, 0 matrix. It may be any size and everything in it is 0. Just in case you ever run across that and need it. Properties of matrix addition. So this is for all matrices. This is just a little mathematical disclaimer. For all n by m matrices. Okay, so the commutative property for matrices as well as just for addition that you learned way back when you learned these properties. I don't know if you ever learned the names of them, but chances are you did somewhere, even if you don't remember them. So commutative property just says we can change the order we add them in and they will still be the same. Doesn't matter which order you add them in, you'll still get the same answer. Associative property would be if we had more than 2 matrices that we were adding together, like let's say we have 3, and we add these 2 together first and then that one, it would be the same answer if we added a different 2 together first and then the other. So let me just add in a matrix C so you can kind of see what I mean by that. So the parentheses would mean to add that stuff together first. And it doesn't matter what we add first because it's all just going to be the same answer anyway. So the advantage to that is sometimes if you look at several matrices that you need to add together and you notice that 2 of them might be easier to add together first because the numbers might cancel each other or something that just makes it easier to work with, then just pick whatever you want to do first and then add the other part later because the answer doesn't change regardless of the order. And the identity property is where if we add the 0 matrix, we just get the same matrix back again. Doesn't matter what order. No, not 0. A. So if we add a 0 matrix to any matrix, we get the same matrix because 0 doesn't change it. The inverse property is that every matrix has an additive inverse negative A such that A plus negative A equals 0. I don't know if you want me to write all that out. Sure, I'm not writing all that out, but I will. Okay, here we go. Every matrix A has an additive inverse negative A such that A plus negative A equals 0. And I actually wrote down negative A plus A because the order doesn't matter. Maybe we're talking about how the order doesn't matter on these because it's going to matter when we get to multiplication. It just doesn't matter when we do addition. So every matrix has an additive inverse such that if we add the additive inverse, we get 0. So that's just a fancy way of saying if we need to subtract a matrix, we can just add the opposite. You just basically go through all of the numbers in your matrix and change their signs, and then you add it instead. Just basic addition rules in algebra that you've learned before. Okay, for example, what's that? Huh? Like for subtraction. So like if you needed to subtract two matrices, you just add the inverse instead. For example, the additive inverse of A is negative 8. So that would be if we basically just take every element, every entry in our matrix and change the sign. So our 3 would change to a negative 3, and our 0 would stay 0. And our 1 would change to a negative 1, and our negative 2 would change to a positive 2, and our positive 5 to a negative 5, and our negative 10 to a positive 10. So that is the additive inverse, which is a lot different than the multiplicative inverse, which we also are going to learn about today. So additive inverse is where you add an inverse instead of subtracting matrices. It just makes it less complicated. You don't have to do it that way, but that's the idea of today. Okay, so far this should all just kind of be basic intro stuff that you might have learned in 9th grade. Okay, so here's our matrix subtraction. So this is where we can use an additive inverse if we want instead of subtracting. Or you can just kind of do it all in your head. Add it. So if we're doing A minus B, doesn't that mean the same thing as A plus a negative B? Yeah. So to do this problem, instead of doing A minus B, we could actually do A plus and do the inverse, the additive inverse. So see how I just took all the numbers in my matrix and I switched the numbers so that I'm adding matrix instead of subtracting. I think it just helps eliminate mistakes. It's not that you can't just subtract it, because you guys know how to subtract negative numbers. It just helps that to be easier to deal with. So since we're doing negative 2, since subtracting the two matrices would be negative 2 minus 8, or you can think of it as negative 2 plus negative 8. Whatever your brain likes better. You don't even have to write out that stuff. It's just thinking through it. So negative 2 and negative 8 is negative 10, and 3 and 1 is 4, 0 and negative 5 is negative 5, 1 minus 4 is negative 4. So I think it does help eliminate errors a little bit to do it that way instead of just like subtracting and remembering that subtracting a negative is like adding the positive. Whatever's easier. Okay. Scalar multiplication. Scalar multiplication. Oh, and I guess I was going to write this here. For matrix subtraction, you add the additive inverse, which is what I told you to do. I just didn't write it. Scalar multiplication. Okay, so what scalar multiplication is where we take a matrix and we multiply it by a single real number. So scalar multiplication is multiplying a matrix by a single real number. The way that we do that is we basically just distribute it. So a single real number like that is just referred to as a scalar. It's like as opposed to a vector. A vector has direction and magnitude, right? But a scalar is just a single number with nothing but magnitude. So single number called a scalar, if you want to say that. Put that in parentheses, and of course my pen changes itself, that will. Okay. We're going to multiply each entry in the matrix with scalar. Okay, so example 3 for the matrices A and B given below, find 2A minus 3B. So 2A would mean that we are taking matrix A and we are multiplying everything in matrix A by 2. So 2 times negative 1, it's like the distributive property. Lots of the distributive property. So 2 times negative 1, 2 times 0, 2 times 3, 2 times 2, 2 times negative 2, or negative 1, 2 times 4. So that would be 2A, right? And then maybe we should go ahead and find negative 3B, because then we'll just be adding those together instead. So for negative 3B, we would be taking the matrix and multiplying everything by a negative 3. So negative 3 times 2 is negative 6. Negative 3 times 1 is negative 3. Negative 3 times negative 3 is 9. Negative 3 times 4 is negative 12. Negative 3 times 0 is 0. Negative 3 times 1 is negative 3. And then we would just add these together, right? So our final answer would come from adding 2A and negative 3B. So negative 2 plus negative 6 is negative 8. 0 plus negative 3 is negative 3. 6 plus 9 is 15. 4 minus 12 is negative 8. Negative 2 plus 0 is negative 2. 8 minus 3 is 5. We're just going over these basic working with matrices just so that we just know how they work. Great. Okay. Getting more time here. Looks like we have a little bit, so I'm going to go save my video.
Oh, wow.